welcome to business statistics class. So in previous video we had studied how to find out moving averages when m is 4, that is an even number, and also we had seen how to calculate moving averages when m is 3 and 5, that is odd numbers. So in today's class, as I said, we will be studying the theory part of the method of moving averages. We'll be studying the merits and demerits, and then we will be studying the second method, that is method of least squares. So in method of moving averages, in this method the short time variations are eliminated by finding the moving averages. So if the time series shows variation with period m, the moving averages with period m are obtained. These moving averages indicate the trend. So if y1, y2, y3 up to so on till yn are the observations, and if m is 3 is the period, the successive moving averages are y1 plus y2 plus y3 by 3. The next moving averages will be y2 plus y3 plus y4 by 3, y3 plus y4 plus y5 by 3, and the next one will be y4 plus y5 plus y6 by 3, and so on. So what does this statement mean is, so we had seen in 3 early moving averages, so m is 3, so these are your y1, y2, y3 up to so on till yn values. So the moving averages is nothing but we are adding y1 plus y2 plus y3 and we are dividing by 3. We will get the trend values. The next successive moving averages will be y3 plus y2 plus y3 plus y4, which is 435, and divided by 3 will give the moving averages. So this is explained in this. So here the first moving average is the average of the first, the second and the third observations. It is written against the second point, which is in the middle most of the first, the second and the third points. Such an association of moving averages with time points is possible only if the period m is odd number. So we can see in 3 years what we have done. We have added these 3 values and we have written it in the middle of those 3, which is we have written the value in between these 3 values. So this can be done only when m is odd. So if m is even number, firstly moving averages with period m are found, then moving averages with period 2 of these moving averages are found. The second set of moving averages can be associated with given time points. So this procedure is called as centering. However, for finding trend values when m is even, firstly moving sums with period m are obtained, then moving sums with period 2 of these moving sums are obtained, and the resulting sums are divided by 2m. These values are the trend values. So this is exactly what we had done in yesterday's class when we were finding 4 yearly moving averages. So this is an even number. What we did was we added 4 yearly moving sums first and we had written, and then we had taken 2 item moving sum, and for this we had divided by 2m, which is 8. So this was the procedure when m is even. So this is the explanation of calculation of moving averages when m is even and odd. So the merits are, the method is simple. If the time series shows periodic variation, this method is very effective in obtaining trend. The demerits are, since the method does not establish mathematical relation, it cannot be used for forecasting. The method does not provide the trend values at the beginning and at the end of the time series. So we can see in 3 yearly moving averages, the first and the last year, there won't be any trend values. So that is a demerit of it. And this method is not much effective when the period of variation in the time series is not definite. So with this, the first method is done, that is the method of moving averages. Now the second method is the method of least squares. So let us understand the theory part, and in the next class we will solve the practical problems. Method of least squares is a method of fitting a mathematical relation y is equal to f of x to a bivariate data such that the sum of squared deviations of the observed values from their estimates is minimum. Here the relation may be linear, quadratic or exponential, etc. The process of minimization of the sum of the squared errors results in some equations called normal equations. So the normal equations are the equations which are used for finding the coefficient of relation which is fitted by the method of least squares. So in method of least squares, with the help of normal equations, we are trying to fit a equation. So you will understand this when we are solving the problems. So the merits of this method are, this method is mathematical, so it is highly efficient. It can be used for predicting future trend. It can be used for deep statistical analysis. And the demerits are, the procedure of calculation is difficult. The general form of the relation has to be predetermined by judgment. If fresh observations are available, the whole procedure has to be repeated. So we will understand this merits as well as demerits when we solve problems based on this method. So for your syllabus, we have only linear trend by the method of least squares. Exponential and quadratic is not part of your syllabus. So let us see what is linear trend. In this method, a relation of the type y equal to a plus bx is fitted to the time series. Here y denotes the values and x denotes the points of time. The constants a and b are obtained by solving the normal equations. So you have to remember these two normal equations, which is na plus b into summation x is equal to summation y, and the next normal equation is a into summation x plus b into summation x square is summation xy. So y, here y denotes the values and x denotes the time points, and we can obtain a and b by solving these two normal equations. So here y denotes the observed values and n denotes the number of observations in the series. If x is chosen such that summation x is 0, then the values of a and b are, so we have to obtain the values of a and b using the normal equations. So what you have to do is, you have to make this summation x as 0. So when you make summation x as 0, then this whole term gets 0. Therefore, we will be remaining with na is equal to summation y. Therefore, a will be summation y by n. And in this term, when you substitute summation x as 0, so this whole terms gets 0. So we will be remaining with b into summation x square is equal to summation xy. Therefore, b is summation xy by summation x square. So remember these normal equations. So therefore, we can find out a by using this formula, which is summation y by n, and b can be found out by summation xy by summation x square. So this will be using in the next class for practical problems. So by substituting the values of x in the trend equation, the corresponding trend values can be obtained. The graph of the trend equation can be obtained by plotting two trend values and joining them by straight line. So this whole method we will understand when we will solve problems. So all you have to remember is these two normal equations, and in these two normal equations, when you substitute summation x as 0, we will get a as summation y equal to n and b as summation xy by summation x square. So in the next class, we will solve problems based on linear trend. So that's it for today's class. Thank you.